Alright, time for a math problem. This is a cool picture drawing robot that was made by the neighbor of a current Fremont High School student, which is pretty cool. And if you look at how it works, you've got a pen, and it's being held just by gravity because it's just hanging from two strings. And those strings wrap around drums up there at the top. Drums are those little wooden dowels with the stars. And then the drums are being rotated by motors. So if we were going to make this, what would we need to do? Let's look in more detail at how it's going to draw. Here we see the pen at a particular place on the canvas, and the two strings that run up to the little pegs that they wrap around have two different lengths, and I'm calling those A and B. What if we want to move our pen right and down a little bit so it looks like this position? What needs to happen with the string? Let's look at it one more time. It looks to me like the string on the left is getting a little bit longer, and it looks like the string on the right is getting a little bit shorter. So if we wanted to write the control algorithm for what are those spindles going to do, we need to be able to say exactly how much string should you let out of the left-hand side, and exactly how much string should you take into the right-hand side. This turns out to be what's called a coordinate transformation problem. The natural way for us to describe locations on the sheet of paper is using rectangular coordinates, where the first number is how far over you go, and the second number is how far up you go. It's the regular XY coordinates you're used to. So let's pretend that the origin's in the lower left-hand corner of the easel here, and that's the point 10, 24. If I want to move the pen 10 units to the right, how much do I have to change the coordinates for A and B? How much do I have to change those two string lengths? That's the kind of problem that I want you to think about. So you don't have any measurements here, so you're going to have to invent all your own the way that I did. So you can call this point 0, 0, and you can assume whatever you want about the width and the height here, but you should just make up some numbers, or if you want, you could use variables. You could call this W for width and this H for height. But whatever it is you do, the kind of thing that you want to produce is some equations where I tell you what are the XY coordinates, and you tell me what are the two string lengths that corresponds to the pen being at those XY coordinates. It would be nice to provide equations that go the other direction also. So if I say, hey, my two string lengths are 50 centimeters and 75 centimeters, you could tell me, aha, here's what XY coordinates the pen is at on the canvas. That's why it's called a coordinate transformation problem. It's because a coordinate system is just a numerical way of describing where something is. So we're translating between two different systems for naming locations. The rectangular system, where the X and the Y tell you how far over and how far up, and this new coordinate system, where A and B tell you what are the two string lengths. But in both systems, you have two numbers that uniquely tell you where a location on the canvas is. Good luck!